Welcome to Get Your FRQ On. This question is from 2015. It's question 2, and it is calculator active. In the question stem, we have two regions R and S in quadrant 1 defined by two intersecting functions. In part A of the question, we are asked to find the sum of the areas of the two regions R and S. Now, in order to do this, these two functions that define these two regions intersect somewhere in the middle. And we need to find that point of intersection because it is not provided to us. Now, since this is a calculator active question, we can set this up and solve this and figure out when these two functions are equivalent, and that will tell us where that middle point of intersection is. So we use our calculators and we want to figure out when f of x is equal to g of x. F of x is the function 1 plus x plus e to the x squared minus 2x. G of x is x to the fourth minus 6.5 x squared plus 6x plus 2. You can see why this is calculator active. It's not going to be very fun to do without one. And using the calculator, we find that the point of intersection there is x equals 1.032832 and y equals 2.401108. We're going to let t be this number 1.032832, and the reason we're going to do that is we're going to use this as a bound of integration, which is already going to be a slightly rounded answer because we're using a calculator. If our bound is also rounded, we have now introduced two steps in the process with rounded values, and it's very likely that whatever answer we get would be very close to the correct answer, but it would not be correct to 3 decimal places, which would then not be considered correct. All right, but since it is a calculator active question, we can use our calculator to find both of these regions using two separate integrals. For the first one, from 0 up until t, the function g of x is above the function f of x. For x between t and 2, f of x is above g of x. So the sum of these areas would be the integral from 0 to t of g of x minus f of x dx, plus the integral from t to 2 of f of x minus g of x dx, and that turns out to be about 2.004. In part B of the question, we are considering only the region S, and we are taking cross sections perpendicular to the x-axis, which turn out to be squares, and we are asked to find the volume of the resulting solid. All right, so since we're only concerned with region S, our lower bound of integration will be t, since S is further to the right than R, and this will be the t that we found in part A. Cross sections perpendicular to the x-axis are squares, so we're going to be integrating with respect to x. And it's actually pretty easy to figure out a function that gives us the area of these squares. The area of the squares would just be whatever f of x minus g of x squared is. So the desired volume for this solid would be the integral from t to 2 of our area function a of x dx, which would be the integral from t to 2 of f of x minus g of x squared dx. Now, these are very complicated looking functions. You don't want to square this and try to find antiderivatives by hand. Please do not try to be a calculus superhero. This is a calculator active question. Use your calculator. The volume of this solid would be 1.283. In part C of the question, h is the vertical distance between the graphs that define region S. Find dh dx when x is 1.8. So if h is just the vertical distance between the graphs in S, then h is just f of x minus g of x. And so h prime of x would be f prime of x minus g prime of x, and h prime of 1.8 would be f prime of 1.8 minus g prime of 1.8. Now, I suppose maybe you could find derivatives for f and g by hand and then evaluate them at 1.8. I do not recommend it. This is a calculator active question. Use your calculator. H prime of 1.8 is just f prime of 1.8 minus g prime of 1.8. Let your calculator do that math. It's negative 3.812.